Hi everyone, welcome back to the channel. Today we're going to look at the 7 stages of AI, and by the end of this, you might be having nightmares. Hopefully you won't. Let's get into it. Okay, so first of all, let's jump into level 1. That's the sort of rule-based systems. These are the most simple forms of AI, and it's basically if something happens, then the machine does something. So think about a basic spell checker that is based around a specific dictionary. A word, somebody types in a word, does it find it in the dictionary? If not, then it suggests a word that might be similar to it. It's just a basically if-then process, and those processes are set by humans. They're not decided by the machine. It didn't understand the language. It simply followed a set of rules that have been programmed into the machine. So these systems don't learn or adapt. They work really well in environments where you understand all the parameters in advance. So another area where rules-based learning was used in the 1980s, but for activities that sort of mimicked the human brain. For example, in sort of medical diagnosis, so you could type in, I've got a temperature, I've got a rash, and the machine could say temperature and rash, that probably means a fever, and so it would take in that information. If that information's there, then it spits out you've got a fever. Very simple. These machines are really effective, but they also show the limitations. Unable to think outside of the box, unable to do anything outside of those predetermined, predefined rules that have been placed in the machine. But these rule-based systems laid the foundations for AI. So when you're using some really complex AI system to generate images, etc., remember they started with these basic machines that did a if this happens, then do that. That's how it started. So let's move on to level 2, and that is AI that is context aware and is able to retain information. So context and retention systems. So these systems are obviously an advancement on the rule-based systems. And what they're able to do is understand something about the context within which they're operating, and also at least have a short-term memory or a sense of its surroundings. So here's how it works. So the system collects data from a series of interactions and learns from them. So if this happens, then we should probably do this. And we've got some data to show that was a reasonable action to take. They don't just respond blindly to a pattern that's been preset. They learn from what's happened previously. Let's think about, say, a smart thermostat. So when you set it up, it just operates on the warm, turn it up when you want it warm, turn it down when you want it cold. But over time, it learns that you want it warm in the morning, so it will make it warm. You want to turn the heating off during the day, it turns it down, and then it turns it on in the evening when everyone comes home from work. The thermostat has learnt what you want it to do, and it's therefore made decisions based on the previous information that you've given it. You see the use of this type of technology every time you go shopping or every time you pick up your mobile phone. You log into Amazon, for instance, and it remembers what you've been looking for and shows you those things again, or shows you offers for those things. It remembers what you've asked for and then says, okay, this person's asked for this, let's give them this to look at again because they might buy it now. So they've retained your knowledge, and they have and therefore giving you back what you might want. This level 2 AI is really powerful, but it is pretty limited to its particular context. Your smart thermostat is not going to be able to tell you what you want to watch on Netflix next, and your Netflix is unlikely to know what temperature you want your room setting at. They're very domain specific. In essence, level 2 gave machines, their first taste of adaptability. It's why tech today feels a bit more intuitive. It knows what you want. It gives you, it can be quite positive in what in your interactions with it, but it is very limited to that specific domain. That's level 2. Welcome to Level 3 AI, domain-specific learning systems. So at this stage, AI moves beyond that sort of basic memory and very specific area that they can work in to the realm of learning. So these systems specialize in mastering specific tasks or domains and takes them beyond the level that humans can do them. But here's the catch. These systems can only operate within a very specific and defined domain, so they're not generalizable in any way. So let's start with one of the most famous examples of level 3 AI, and that's IBM's Deep Blue in 1997. So it defeated world chess champion Garry Kasparov. This was a watershed moment for AI, showing that machines could analyze massive amounts of data, potential moves and counter moves, faster than a human could do it. However, you ask Deep Blue to play drafts or complete a Sudoku, and it's a bit rubbish. It's very good, but only in its own domain. So another transformative example is IBM's Watson for oncology. And there it's able to search through piles and piles of patient data and spot patterns in a way that humans can't do it. Really effective at sifting through lots of data and making a diagnosis based on what has happened before. And we're starting to see this used in the National Health Service in the UK to analyse visual data, so scans, etc. And by analysing many hundreds of thousands of scans and picking up the patterns, we're able to start identifying abnormalities well before the human eye would actually see them. Really powerful stuff. Another example of domain-specific AI will be in the manufacturing sector, where robots are now building vehicles. If you go to one of the modern OEM car manufacturers, you'll find that the vehicles are assembled by robots. And these are not robots that are just repeating the same thing over and over again. They're able to sense where they are, they're able to make small adjustments, they're able to spot problems when they happen. So these robots can look at their environment, they can make decisions, they can repeat tasks, they can work over and over again. Ask them to be able to pick up a human emotion, no idea whatsoever. These sorts of AIs are also used in the financial sector, analysing tons and tons of data and spotting patterns, and then making suggestions about whether to invest or not invest. Their ability to process data far exceeds anything a human could do, but they can only do it in that financial setting. Ask them to then go and have a look at data sets, health data sets, and they would be lost. So how do they work? So they're heavily reliant on something called machine learning, and this is learning that is managed. So you train the model on these very large data sets, and then over time it learns the patterns, and it optimizes its responses to those patterns. Take Deep Blue, for instance. Its operators fed thousands and thousands of chess games into it, so it could learn all the different patterns, all the different next moves, all the different setups, so that it had this enormous database of all the possible moves that you could have in a chess game. So these systems are amazing and can do things that humans can't do, but they're very specific and can't operate in that generalized field. And that's what we get. That's what we're starting to get to when we get to level 4 of AI. Okay, so welcome to level 4. So these are reasoning systems, and this is where I think we probably are right now. AI is beginning to show something like human-like problem solving. These systems can analyze data, they can draw inferences, and they can make decisions, even in scenarios where they haven't been specifically programmed to deal with. How is this different to level 3? Well, Level 3, very domain specific. Level 4, we're starting to break out of that domain specific area, and the AI is able to think about an issue and give you a response to that issue, suggest an outcome, even when it's not been specifically programmed on that area or domain. And what makes this unique is that it's able to understand and weigh up problems without potentially knowing all of the data, without having incomplete data. And that's the hallmark of reasoning with AI. One example of these reasoning systems might be fraud detection. So if you live in the UK and suddenly your credit card is used in a foreign country, the system may say, oh, that's interesting. That person has recently used their card in the UK. Now they're using it overseas. That might be a fraud issue. They looked at ways that you use your credit card. They looked at ways that other people have used their credit card, and they would identify a pattern, and then they can make a decision. They don't know if you are on holiday. They don't know if it was a perfectly reasonable transaction, but it will make a judgment. This feels a bit odd. We might just stop that credit card and just check with the owner of the credit card. It's used some reasoning. Autonomous vehicles is another area where this reasoning will need to be used. You couldn't possibly plan every single situation into the computer of a car, but it can say, okay, it's now raining. Oh, there's a construction works coming up. Maybe I need to slow the car down, be aware of my surroundings, other vehicles around me. So it's never seen that situation before. It's brand new to it, but it can make a reasoned judgment on what to do in face of what it sees ahead of it. For those of you that use Google Maps, there it is. Say you're driving with Google Maps. So I have in my car a standard sat nav, and my wife uses Google Maps. And I know that if I'm driving in my car, it will say this is the best route to take wherever I'm going, and it will take me there. Whereas Google Maps will say, okay, this is the best route. Oh, there's a blockage in this area. Is there a better route? Yes, let's find a better route. And then even when we're in that journey, it will say, oh, there's an even better route now. Do you want to choose that? So that active engagement in what's going on and the information that's coming in, and then making decisions for you, this is your level 4 AI. So how do these systems work? So they, like the previous levels, they work on machine learning, but they also have something embedded called symbolic logic. And so the machine learning can look at great data sets and identify patterns, and then the logic side of it will say, okay, well, if that pattern happened there, then this might happen here, and it can create some inference from the decision making based around the machine learning. So many level 4 systems will also sort of have a guess, have an idea, and of course this provides some issues, some problems. We know that ChatGPT 4, for instance, will hallucinate. It will have a guess at what a suitable answer might be. So while being able to guess and try things out makes absolute sense, it can provide some sort of negative outcomes. I think we have certainly see that at level 4 with systems like ChatGPT 4.0 and ChatGPT 0.1 preview, which shows its reasoning, we're into that AI, that level 4 AI state. But there are clearly some limitations. So the AI can't truly deal with the unexpected. It has to have some frame of reference for it. And you might find that, with things like autonomous vehicles, that where the interaction with humans or animals is perhaps completely unpredictable, then the AI might just close down and stop. It doesn't know what's going to happen. It doesn't know how to make a decision. So it is limited by its frame of reference and what it already knows. We also know that there are some ethical issues. If the data that the AI has been trained with is has some biases based in it, and given it's been trained on data that we've given it, on our data, it will have our biases, and therefore it can both amplify and maintain those biases. So we certainly have to be careful about how these systems make these decisions. And of course, as these systems become more complex and have an ability to make decisions, then we need to ask the questions about who's accountable. Is it the people that programmed it? Is it the people that created the data? Is it the person operating it, or is it somehow the AI that's accountable? Now, it's something that I talk about quite a lot on the channel, and in my view, the operator, the person operating the vehicle, the person writing the blog, retains responsibility. And I think that's important for us to remember, that we must retain responsibility for the outputs and outcomes of AI, certainly at level 4, and as it gets more complex and perhaps moves into level 5. The level 4 is where we are today, and it's still developing. It gets better all the time, and thank goodness for that. Otherwise, I'd have nothing to make videos on. And they don't just think within their domain. You can put them to task in lots of different ways. So really, really powerful, and a real leap in a tool available to us. And I think that sort of generative AI, that thinking and reasoning AI, is what's seen the big rush to this technology. It's been around for a long time, but this new definition, this new way of operating with AI makes it really powerful, and we're seeing that take over lots of things that we do. Okay, so we've done where we are today. Where might we be tomorrow? Let's have a look at level 5. Okay, so let's jump into level 5, artificial general intelligence. And right now, the holy grail of where people are trying to get to, where all this money that's been put into OpenAI and Google and others is trying to get to. So unlike the previous levels of AI, then artificial general intelligence isn't limited to a single domain. Is able to think, learn, reason across a whole series of different domains and act just like a human. And this is the point where machines will truly start to emulate human intelligence. So what does it take to build AGI? Why is it so challenging? Let's have a look. So AGI refers to a machine that can undertake any intellectual task a human can. It's adaptable, meaning that it can transfer knowledge from one domain to another. So imagine an AI that's not only good at diagnosing medical diseases, but can also create the best marketing campaign. These use completely different skill sets, and AGI would be able to switch from both of those. The possibilities are endless. AGI could revolutionize how we educate, how we govern, the medical sector. Just think about something that has the intelligence to be able to switch from different domains, be able to bring learning from different parts, learn itself, relearn itself, and then make decisions based on that learning. Will it perhaps be able to solve some of the big global issues like climate change or hunger, just by understanding different ways of dealing with things from a different point of view, by synthesizing knowledge from multiple fields? So we've got a storm here in the UK. Think about AGI that could identify the storm, plot where the storm is going to go, decide which resources needed to be moved, who needed to be evacuated, all with sort of human-like intuition, understanding how these things are going to happen in great detail. We're not that far away. And AGI won't be just about solving problems. Think about bringing that sort of power to the creative sector, creating new buildings, creating new artwork, new literature, etc. This technology might be able to take us to whole new levels of understanding of that creative sector. So what do we need to get there? So we already have neural networks, and these are very good at learning things. But I guess it's understanding that cause and effect issue, being able to understand that, having a deeper understanding of how things work. We will need to get to that position for AGI to be really there. Another key area will be its ability to transfer learning. Now, we are seeing some of that in the current models, but it's not brilliant at it. But that ability to be able to take a piece of learning from one area and then apply it in another area and be able to test it out and see whether it works, that will be really essential if it's able to generalize its knowledge across different fields. So AGI brings enormous potential, there's no doubt, in moving healthcare, the ways we work, the way we manage our planet, etc. But obviously that creates enormous risks as well. Enormous risks about job displacement, about autonomy, who's actually making decisions, and what happens when AGI, and it will very quickly, surpasses human intelligence. Who then makes the decisions? Is it the AGI or is it the humans? So AGI isn't just a technical issue, it's a moral and ethical issue as well. How do we make sure that as this technology improves and increases and breaks out of the limitations that we currently see, how do we make sure that it's done in a way that supports the betterment of the planet, of the people on the planet? And how do we deal with those actors that are not necessarily interested in that and interested in personal gain? These are all challenges that we're going to need to wrestle with as we approach AGI. While AGI is not there now, there's a lot of work that's moving us towards AGI, and there are lots of predictions about when we might achieve it. 2026, Elon Musk, I think, has said, and there are other predictions. It doesn't feel far away, and probably within this decade. That's concerning. So AGI level 5, but there's 7 levels. Let's see what's next. So level 6, artificial super intelligence. So now we're getting into very much into the realms of science fiction, and this is not just intelligence that is similar or even better than us. It's a whole new form of intelligence that we can't even imagine right now. So artificial superintelligence would not have the limited cognitive abilities that we have, or we might program into artificial general intelligence. It can process information at unimaginable speeds. It has access to all of the knowledge that has ever been known and can create its own knowledge and make decisions that it would take humans years or even centuries to complete. The potential benefits of ASI are staggering. It could solve scientific problems. It could end diseases. It could reverse climate change. It could even help us to colonize other planets. For instance, consider ASI developing a whole new way of generating energy that we can't even imagine today. ASI might understand physics in a way that we couldn't possibly do, or chemistry, and develop brand new products and compounds that could change the way we live and we interact with our planet. ASI could create fairer economic systems. It could predict and prevent wars. It could optimize resource distribution, etc. It could eliminate hunger. It would think holistically, analyzing billions of different variables and simultaneously find solutions that humans just could not reach. And of course, it could enhance how humans operate. Imagine having a connection to a neural network that gave you access in your own head to all of that reasoning, all of that information that was out there, enhancing the human as well. So how will we get there? So it will require algorithms, it will require the AI to be able to continually improve itself. So not working on the basis of what humans have created to create the AGI, for instance. It will be able to break out of that and create its own knowledge and understanding of how to do things even more efficiently and more effectively. It will be outside of our control, and that would create a knowledge explosion, and it would create its own behavior, if you like. It might develop abilities that we hadn't specifically programmed into it. It would be able to invent its own language, for instance, and find entirely new ways of processing the data. So while it sounds very exciting, it also brings with it enormous risks. With this enormous explosion in knowledge and capability, and it no longer requiring humans to guide it and create it, the AI could take over decision making. It could create its own levels, its own way, its own morality, and even if by mistake it could end up causing immense damage to the human race or even wiping it out. To ensure that AGI and ASI benefit the human race, we will have to make sure that we are building in really strong ethical frameworks that are agreed across nations, that are managed and led by people that really think through the different variables that are required. How do we prevent misuse from negative actors? These are really, really critical questions, and we need to start having those conversations now. Now, while ASI remains a theoretical point, I think we need to start having those discussions now, because as we get close to AGI, and I think most people feel that AGI is achievable, as soon as we get to AGI, ASI looks much more possible because we'll have the technology to get us to that point. So level 6 ASI feels like the ultimate frontier of intelligence. It could solve humanity's biggest problems. It could cause a whole series of problems itself. So still scary, and hopefully as this technology builds, we will find the solutions to make sure that it is a technology that benefits humanity and that we are able to remain in control of it. So now we're really jumping into the sci-fi world. This is level 7, the Singularity. So the way to think of Singularity is as a point somewhere in the future where artificial intelligence advances so rapidly, transforms the whole paradigm of how we operate, how we live. So it's not just a technological leap, it's a paradigm shift. So what is it? What does it mean for humans? Will humans still be around? Will we coexist with this singularity? With this super intelligent systems? Let's explore that. The singularity could take humanity in lots of different directions. On one hand, it could lead to a golden age of prosperity, curing diseases, ending poverty, etc., and unlocking the mysteries of science. On the other hand, it could result in the complete loss of human autonomy or even human life. Of course, this fusion between human and AI could make humans smarter, faster, even immortal, by transferring the human knowledge into a digital form. Another scenario might be a fully autonomous society where AI manages everything and we just sort of live in the society. We might play a sort of secondary role, I guess. Not sure I want that. We'll see. I guess the question then rises, what happens to humans? So at the moment, the singularity is purely science fiction. But you can see as AI improves, as we get AGI, then is it possible to get ASI, and then perhaps the singularity? We don't know. We'll see. So if the singularity is possible, how do we prepare for it? Do we stop it? Do we allow AI to get to a certain level and then put a cap on it? If that's the answer, then how do we control those countries where we don't have control, that might think that there's real advantage in pushing closer and closer to the ASI, and when we get there it might not be possible to stop the singularity? These are really complex, challenging issues to think about, but certainly I'm sure will give philosophers much food for thought over the next 10-20 years. So what do you think? Let me know in the comments below. Are you concerned about AGI? Are you concerned about ASI? Are you concerned about the singularity? What is it that worries you about all this, and what do you think we should do? It'd be really great to start a conversation, so drop your comments below. Okay, if you want to learn more about this and want to learn how to use AI to study, have a look at this video here about Notebook LM. At least it might stop you having nightmares. See you soon.